Hey guys, this is. Wait, which one of us is going first?
I'm pretty sure it's still my turn. Hey guys, this is Andrew.
And this is Jules. Welcome back to Code School. Today we are going to continue talking about Wackodot. Andrew, I have to say, I'm pretty impressed with how great your code is on this game.
Oh, well, thanks. I'm pretty proud of it.
Yeah, it was so easy to copy almost all of it to use for my React game. I only really had to change the playing state and get rid of those colors, but the UI context class we created made that part a breeze.
I guess it's like they say, imitation is the sincerest form of flattery.
But before I get into my game, let's finish talking about yours. You had to draw circles for your game, and you also had to detect collisions, but we haven't really explained how to do either of those yet in Pygame.
Drawing is actually very simple and quite similar to the way we drew things in SimpleGUI. The syntax for drawing circles is pygame.draw.circle. The arguments we pass in are the surface it's being drawn to, the color, the center point, the radius, and an optional outline width. If width is left off, the default is 0, which means the circle will be solid. The one potentially confusing part is that drawing a circle returns a rect object. In fact, drawing any shape returns a rect object, whether it's a rectangle, a circle, a line, or a polygon. The rect object is actually a very useful thing, though. It makes handling collisions later extremely easy. In fact, in most cases, we don't even need any complicated math.
No map? That's definitely a selling point. In my game, I didn't use any circles. Instead, I used squares. For that, I used Pygame draw rect. The arguments for it were the surface it was being drawn to, the color, a rect object, and the optional outline width. The confusing part was the rect object. Creating a rectangle object returns a rect object, but in order to make it, I need to pass it a rect object. After a little too long on the horrible green website that is pygame.org, I discovered that creating a rect object is actually as simple as calling pygame.rect and passing it the top left corner point location and the size I wanted the rectangle to be. I also discovered I could pass these as one tuple of 4 values or 2 tuples of 2 values.
Another great thing about rect objects in Pygame is that they automatically calculate any changes to all their attributes whenever you change just one of them. For example, let's say I have a rect object located at 0, 0, or the top left corner of my window. Now let's say I want to move it to the center of the screen. I can simply tell it to change rect center to width over 2, height over 2, and it will automatically change the location information to the correct values. These attributes are called virtual attributes. Here are all the attributes. Assigning to size, width, or height changes the dimensions of the rectangle. All other assignments move the rectangle without resizing it. Notice that some attributes are integers and others are pairs of integers.
The best part about the rect object is collision detection. If we want to detect if a mouse has clicked on an object, we can use pygame.rect.collidePoint. So when we handle a mouse click event, we can get the position of the mouse with event.pause. Then we just simply use the syntax that is our rect object dot collide point passing in the mouse position. This will return a Boolean value, true if there is a collision, false if there isn't. And not one bit of math was needed. Try doing that in SimpleGUI.
It can also tell if two rectangles are overlapping at all, or if any rectangle is inside of another, or if a rectangle collides with the first or any of the rectangles in a list or dictionary. In all of those instances, we simply call the method with our rect object, then pass the needed arguments. All the math is done for you. And the really great news is that these same methods will also be available when we use sprite images together.
Wow, that's awesome! That makes me look forward to adding sprites.
Until then, why don't you show me your game? Or should I say my game, since apparently almost all of the code is mine.
Absolutely! Since this week we are dealing with timers and drawing objects and handling basic collisions, I thought React would be a great game to demonstrate all those things. It starts exactly like yours, with a timer event-triggered switching splash screen. I added instructions on the title screen and changed the timer to allow the player time to read them. The high score screen is exactly the same as yours, except I shortened the distance of the dotted line a little.
I can see that you kept the game start state the same too. Can I just point out once more how amazing and beautiful game states are?
I'm definitely a huge fan. I created this whole game in just a couple of hours, and it would have taken even less time if I didn't spend one whole hour finding the perfect shade of pink.
Okay, so back to your game. From glancing at the rules, I gather that the object of the game is to destroy all the bonus blocks I can. But I have to avoid the penalty blocks, and I also have to click on at least one non-bonus penalty block every 2 seconds, or I get a penalty for that too. And if I get 3 penalties, I lose a life, and after 3 lives the game is over. This doesn't sound too hard. Let me give it a try.
Great! You play while I'll explain what's going on. You can see that all the blocks are moving around in the playing area. They change directions when they encounter the sides or bottom and an invisible wall under the reporting area. Just like in Whack-A-Dot, when the player loses a life, the game transitions back to the game start state, which does a ready check countdown. The countdown on the right side of the playing screen shows the time until the bonus and penalty blocks will be changing colors again. I don't have the blocks bouncing off each other, so it's possible to click multiple blocks at once if they are overlapping. When all the players' lives are over, it goes to the game over state, just like Whack-A-Dot. If the player has a high enough score, they get to enter their initials too.
So basically, with the exception of the playing class and a few design changes, this game is actually Whack-A-Dot.
Pretty much. And the really good news is that this is the optional assignment for this week. Steal, appropriate Andrew's code, change the playing state, and recreate React. Try to have 2 separate timing events going on at the same time, like I did with the 2-second requirement for destroying a non-bonus, non-penalty block, and the 5-second countdown for changing the bonus and penalty block colors.
Also, try your hand at creating your own context so your game doesn't look anything like mine or Jules. And while you're working on your code, try temporarily making the initial state the playing state so you can go right to it without the hassle of going through the other states.
The React template is up on our GitHub page, along with the recent versions of UI, File Helper, State, and pgextra modules. Be sure to update your copies of those files so you don't get any errors from this new code.
You can find everything by going to our forum and clicking on the From SimpleGUI to Pygame category. There's a link to our GitHub page there, and the assignment details page is at the top. So Jules, what exciting things have you got planned for next week while I'm gone? And whose code are you going to be stealing then?
Hey, I like to consider my plagiarism exploits as creative time management. And next week, I plan to have an entire video of your bloopers. Then I was thinking another one could be all the things you do wrong in your code, like forgetting where the spacebar is on your keyboard.
Something tells me that won't entertain everyone else as much as it will you.
Yeah, you're probably right. I guess I'll have to come up with something else.
Well, good luck with that, and thanks for watching, guys. Have a good week. Remember to subscribe and join us on our forum.